now let's go here. There are several things that happened in the past, and I want to highlight a few of these as an example. And this is more or less in the field of cybersecurity, supply chain security. These are new topics that are coming more and more to us. And right now, a lot of things are going on different parts of the world, and this is influencing a huge part of the industry, even in Germany and other countries. And this is why software developers have to prepare against attacks on several stages inside the supply chain. And what can we do as a core developer? So I'm as a developer, I'm sitting down there and I'm coding and I have to do my daily job. So what should I do? What can I do? And what are the first steps to start? So this is more or less the background. I will give you a little bit information about the history, why things happened, what happened, and I will give you some advice what you can do in the future so that you can start tomorrow with what fits to your project. Okay, so by the way, as mentioned, my name is Sven Ruppert. I'm from Germany, and as you can see at the picture, mostly I'm running out in the woods. So if you want to see some talks like this, but straight out of the woods, then I highly recommend to visit my YouTube channel. I have a German one and I have an English one. So make sure that you're selecting the right one. So if you're searching for the English one, Sven Ruppert in English, and then you will see outdoor style IT related videos. So it's just a hobby project of mine, and I started during the pandemic with this. So it's a tiny one, but I love it. So where's my slide? So what happened? What happened and what is more or less a key point where we're starting with? So we had this big thing that's called Solarwinds Hack. I don't want to go into all details. I'm sure a lot of you already were able to read a lot of stuff about it. It was everywhere. But what was the lesson learned? So the lesson learned was, more or less, the short overview. So this DevOps environment from this company that's delivering with automatic updates to a bunch of customers, and we are talking about here about, I think, 300,000 customers, and a customer of them is not only one server, it's software to manage networks, this Orion platform. As if you have 300,000 customers, you have 300,000 networks, okay, that you are delivering. And this hacker group, what they have done is they broke into this company. Before they stored something from FireEye and different things, or the whole tool set, but they broke into this environment where they are producing the software, and instead of encrypting stuff or destroying things, they just manipulated the CI environment. They manipulated the CI environment in a way that with every build, the binary was compromised. And then with this automatic update, it was just delivered to a bunch of customers. If I'm not completely wrong, I think during the first 3 or 4 days, they infected, I think, up to 12,000, 30,000 of customers. And it means not customers, it means networks. 13,000 networks infected. It's a huge thing. So what does it mean for us? For us, it means we have to protect now against two sides. We have to protect against what we are consuming, so not consuming bad stuff or compromised stuff. And we have to make sure in the same way that we are not distributing stuff. So we have to make sure that the binaries we are creating are not infected or, added with malicious packages as well. So we have now these two sides, because distributing malicious stuff or compromised binaries is not only the technical dilemma what we have the challenge with that the customer is losing trust in us. So it's a big thing. So now we are in the middle. We as a software developer, we have to do now some things. So supply chain security is a broad topic. And what we saw during the last, let's say 3 years, is that things are changing. Things are changing. It started before the pandemic. During the pandemic, it really changed it. And during the last half a year, it changed dramatically as well. So we have now a thing that we have some key factors that are now quite dominant in this supply chain security. Supply chain security in general means that the whole process from the idea up to something is delivered to the customer It's a whole supply chain, and everything is involved in the supply chain, or it's a target where we are going through. So, for example, everything that we are producing, consuming, every third-party thing, services, deliveries, whatever. So it's a whole thing that is a supply chain. And everything can be attacked. So this is a general supply chain. It could be the manufacturer, material, it can be software, it can be, and so on and so on. So what we see is that these attacks are more and more specialized. Say, for example, early days we had individual groups or individuals that are attacking a system, and it was more or less their individual task or effort to do. But now we see that different groups are joining forces and working together, and they're sharing resources, sharing knowledge, sharing even individuals that are working partially for different cyber criminals. And this is something that is changing the game because we now have a big ramp up in resources. We have expanding motives in ransomware, not only in terms of I want to earn money, but more and more we have political motivations. I don't want to go into many details, but it's more or less used in the same way just to attack systems. And the main thing is previously companies just said, okay, this part of the supply chain has a value of $1 million. And if there is something with ransomware and they want to have less than $1 million, we're just paying and done. And it's not working anymore because sometimes they just say, yeah, give me money, but they never want to do something if they got this money. Improved ecosystem hygiene is pushing threats up to the supply chain. Means if I'm as an SMB company is working for a big company, and I'm part of the supply chain, and this big company is increasing the security bar. So from day to day, they have more power, they have more resources, knowledge, IP, and so on and so on. So they're raising the bar from every day, means that the attackers are not targeting to the main target. They try to sneak in over left and right to other parts from the supply chain to come into this company. It means for me as an SMB company, maybe with just 10 or 15 developers, now I'm the main target because I'm delivering something to a big company. And yeah, there is something else. So even if I'm in an SMB company or a small company, and I'm working for a big company that is unfriendly, and this is a quite hot term right now, you're under heavy attack, not only from cyber criminals. We see even in Germany that we have a lot of attacks that are coming from governmental institutions. I don't want to go into many details, but I think the pressure is increased dramatically. So vulnerabilities in cloud hardware infrastructure, most people are just thinking about supply chain security in terms of software, or if they're thinking in terms of software about bugs, malicious code packages and so on. But we have hardware vulnerabilities as well, so that in cloud environments, I can read the memory from other instances and so on and so on. Okay, so we have different things that are evolving, and this is something what we should have in mind. But bringing this down to the software development. So I'm cutting now left and right everything from the supply chain, just focusing on the software development. It mostly looks like I'm a developer, I'm creating source code. This source code will be hosted somewhere, then pushed to some kind of CI environment to build some binaries, and then it's going to some repository where it's held, and then it will be delivered to something. I will go to this picture in a little bit more detail a little bit later. By the way, this picture is copy pasted from the project Salsa. I will explain what this project is in a few minutes. But what we see is that if you're just cutting down the whole piece from I'm creating source code until a binary is delivered, I have some key points here. I have more or less some environments, and I have some things that are moving, and this is more or less source code and binaries, and then some infrastructure things. Okay, so this is more or less where I want to go through. And if you start reading about cybersecurity or whatever you want to see, DevSecOps, different terms, you will more or less find the way to some basic terms, and it's important to know what these basic terms are and what is the impact on this. And for example, one basic term here is that you will see quite fast this ZAST, DUST, ICE, and RASP. And ZAST is a static application security testing. It means that you have access to all components. It means all dependencies, source code, configuration, everything. And then you can scan this for vulnerabilities, maybe for malicious code packages and so on, and try to identify if you have weak parts or parts that you can harden. And for this, you don't need to run anything. You just have all parts in front of you, and then you're scanning. What you have is everything from static semantics, but what you're missing is all the information from the dynamic context. So everything that is just available during the time the application is running. The good thing is you can start immediately with ZAST. The bad thing is you're missing the dynamic context somehow. So you can scan, for example, for ports in configuration, but really the dynamic behavior you don't catching with this. On the other side, you have this DUST, this dynamic application security testing. This is completely the other approach. It's not the approach that you're analyzing all bits and pieces inside. You're looking from outside at this app, and you're working like this hacker approach. And mostly it turns out that you're using some tools that are attacking your ramped up application. And what they're doing, they're mostly going over the most common vulnerabilities. These are SQL injection or whatever. So they try to break into the system. They're looking from outside to the system. They're not really, they have no knowledge about what's internally going on. Maybe they know a little bit, okay, that's technology is used or whatever. But in the end, they're looking from outside. So what they have is they can attack over the dynamic behavior, but they have no clue about the internals, more or less. They can guess something, but they have no access. So they can just test indirectly. And this is a big change or a big difference between with ZAST, you can scan 100% all components. With DUST, you can scan the dynamic behavior, but just from outside and indirectly. The bad thing with DUST is it's very time consuming because you need a running application, and the scan is mostly limited by runtime, params, and resources and all this stuff. And this is leading to ICE. If you're combining both the ZAST and the DUST approach, you're talking about the interactive application security testing. In general, you can think about it like a security debugging, or like a performance test, it's a security test. So you have the whole application, you have access to all bits and pieces, you're attacking the system, you're checking inside with this debugging approach, what's going on, you're modifying the attack vector, and so on and so on. This is a very good approach, but you need humans to do this, and you need humans that are well educated. It's nothing what you're learning just in 5 minutes, okay? And then if you have this one, you have all these testing approaches. Then you have the fourth part, and this is RASP, it's Runtime Application Security Protection. It means you have this application running. RASP makes only sense on production because this is the target here, or the goal here, is to identify an ongoing cyber attack. So it's mostly an agent-based approach. So you have this environment, like in performance, so it's this APM tools, you have this agent that's manipulating the application in terms of putting in more information, that you are getting information out of where is data flowing, what data flows are active, and so on. And then with machine learning, you can more or less in real time identify if there's something that is not like always. And then you can identify, okay, here's something that looks strange. And then you have two possibilities. You can just monitor and notify. You can send an email or whatever, alerting. And the other thing is you can just automatically block or shut down the application. So with RASP, that is just identifying there's an ongoing attack. Okay, that's the last wall of defense what you can have. And the bad thing is, if you're identifying something, then it's just too late because it's ongoing. So RASP is not the only thing you should do. RASP is a perfect addition if you have money and resources to do this as last line of defense. But this is not the basic approach you should start. With IST, you have the same challenge. It's a perfect approach, but you need very trained and skilled people to do this, and it's a human that must do it. It's not a machine that's doing it only. So it's not easy to scale here, and this is something you can do later. Dust is inside your CI environment very late because you need something that is running, and you're catching dynamic context, but not looking inside the whole machine. And then the easiest part and the thing you can start immediately is static application security testing. And this is, for you as a developer, the easiest part to start, because you can do it immediately, even without knowing something about vulnerabilities. Okay, so and this is what I really recommend. Start with Dust, maybe then add Dust in your test environments. If you have the chance, maybe IST, and if you have money, you can do it with Rust. So okay, running a little bit here in terms of time. So what I want to show here is not cloud native's bad or worse or whatever. It's just an excuse, because we have the service-oriented architecture, different things that are communicating. So who's able to make sure that this dividing things in different microservices is good? It's done by humans, so you have really no tool support. It means this is something that's done by humans. And then there's security by concept, okay? That's not done by tools. The communication itself is a little bit, okay, now you have different nodes, they start communicating, and then what the machine can do is they can encrypt the channels, but they can't decide. It is difficult to send this information and that information over the same wire, okay? Tools are not able to help here. They can just encrypt the channel, okay? But if you're going to container-based infrastructure, something that's running somewhere, you need resilience patterns and all this stuff. The machines are stronger and stronger and stronger, because now they can work in a generic technology, or technology is a big thing, not the domain-specific thing. So here it's more powerful, but the biggest advantage, or the easiest way to start with this, is really during the DevOps or DevSecOps phase. So during the time you're creating this stuff, because here tools have all the knowledge that is necessary to do something, and they can help. And yeah, so just make sure that with every layer you're adding, for example, the application that's running an operating system and so on and so on, you can just add vulnerabilities. You can never remove vulnerabilities. You can add 0 vulnerabilities, but you can hide or mask or wrap vulnerabilities, but you are never able to remove vulnerabilities. This means that with every layer, per definition, we're adding 0 or more vulnerabilities. Same with compliance issues, but I'm not focusing here on this one. And here again, you have two things. There's a technical approach. This is where the tools are strong, and then you have domain-specific things. Can I misuse the process? This is done by humans. The most people forgetting the tool stack itself. So they are checking their own application, but who of you is using a Jenkins, downloading the Docker image and scanning this one and start hardening this Docker image inside your own network? A lot of people are not doing it. So I saw so many projects that are not hardening their agents, or they never checked if their compiler is not compromised, and so on and so on. And there is some very interesting thing. If you want to read more about this, search for the term evil compiler. You'll find some very interesting articles there in the field, and they are quite old. Okay, so this is all the tech layers, and then you will find soon this term shift left means start as early as possible with security, and then most people thinking about, okay, what's the first that makes sense? Before I'm coming to this one, I want to highlight a little bit on all layers. Whatever technology layer you're using, you have mostly some kind of binary manager in the background. Why? Because you're not reinventing the wheel. So if you're working with Java, mostly you have Maven as a dependency manager. In Linux, you have Debian, Docker, Helm, and so on and so on. But think about tooling. I'm grabbing my compiler, I'm grabbing this and that, thinking about a generic repository. Okay, so in the end, what you have is always some kind of dependency management, version, binary, location, coordinates, and all this stuff, and then some metadata that's describing this one, and then you're building the composition over all technology layers. So we at JFrog, we have this knowledge because we have this Artifactory, and inside Artifactory we have all these repositories, and then it was a good way to think about, okay, if you have all this metadata and we have access to all binaries, then it makes sense to start there with scanning as well. And this is why we connected X-Ray, this security scanner, just generally speaking, to Artifactory. Okay, and this combination makes possible to have this whole metadata and the binaries together over the whole tech layer, so that you have the full impact graph. We have a few things that I want to highlight. If you're talking with a management, mostly you're talking more or less about the same things with different words. But what I see is if you start implementing security related processes, then what I'm never understanding is, for example, the management's going through you as a developer and says, there's a use case, please take this use case and make it happen. Okay, you're taking the use case description, you're implementing it, you're testing it, you say, okay, well, I think it's done. You decided as soon as possible, that's cool, and then you're pushing it to production. Nobody else is involved. And then, yeah, well, and then you have a security hole. And then, oh, processes are changing. Now you need permission from this guy and this extra thing and that extra thing, and that's just killing time. And time is very, very, very important if you're fighting against known or vulnerabilities or malicious packages and all this time. So time to market means speak with the same words in terms of, okay, if you have a use case and you need it as fast as possible in production, killing a vulnerability is exactly the same. Okay, please have short, fully automated processes and don't waste time. Make or buy is more or less the same. So what does it mean for us? Everywhere, okay, we need knowledge. We are hiring an external consultant because he has experience. He is doing all this stuff, and then he is implementing this stuff and running away. So, okay, everybody understood that you can have some positive and some negative effects with this. But for us as developers, it's every time the same. So we have to decide every day, make or buy. Should I write this PDF library by myself and learn all these things and doing all these mistakes, or should I grab an external dependency? Should I buy it? Okay. And immediately I have the same challenge. How should I trust, or how can I trust this external stuff? If you're looking at all the layers, it's very important to see that in every layer, you have some parts you're doing by yourself and some parts you're grabbing from outside. And here it's mostly that the part that you're doing by yourself is very, very tiny compared to the things you're grabbing from outside. Mostly, if you're writing a few 100,000 lines of code, you're grabbing a few million lines of code via dependencies. If you're going to the operating system like Linux, it's even worse. You're writing a few configurations and you're grabbing million lines of code even with a kernel, and so on and so on. And Docker even starts with a from statement, and so on and so on. And again, don't forget the whole tool stack. This is a dependency because you're grabbing binaries. You're not creating your own compiler, or mostly you're not creating your own compiler. You trust this. It means if you start thinking about where should I start, or what should I scan in the beginning, my own stuff I'm writing or something from external, the easy answer is the low-hanging fruits. If you start with security, focus on all dependency, because this is a maximum dominant thing in your whole application over the whole thing. Not touching here is a part about compliance, but it's more or less the same. Compliance over all dependencies is good to check because it's the biggest part. But if you're talking about vulnerabilities, what do you need to do it? You need some tool that's scanning for vulnerabilities. The machine is doing the job, so it's not time consuming for you. And if you find something, then the human has to decide, what should I do? Okay, so you can start immediately. Yeah? There's nothing critical here. Compliance and vulnerabilities. I'm just mentioning it to show the difference. Compliance, if you have somewhere the wrong license, what you need is you have to grab out this single piece and you have to replace this with a semantic equal implementation. And this over the whole tech stack, okay? But it's not, affecting other layers, okay? If you have here a license issue, it doesn't mean that you have license issue somewhere else or you can't combine them, okay? So you have just single dots. But with vulnerabilities, it's different. Different vulnerabilities, even if they are just minor critical, for you, or general speaking, minor with a low CVSS value, then it's okay, but you have to understand the whole impact graph of the whole tech layer. So it makes no sense just to scan Maven or just to scan my Docker image. You need to understand the whole metadata over all layers to identify where are the possibilities, what are the possible attack vectors. And only if you really will get the whole impact graph of the whole tech layer from the operation system or from the production system, then you're able to identify which one is bad, which one is good, and so on. Because if you don't have the context of your environment, you're not able to use the CVSS values right, because then you're not able to calculate environmental metrics. Okay, So it means, okay, if you want to know more about CVSS and environmental metrics and the CVS calculator and all this stuff, on my YouTube channel, I have some talks and some videos about it, and I'm explaining how to calculate this and what there. But in general, you need the information about the whole context to understand the impact of the vulnerabilities in your system. Okay, so vulnerabilities have a lifetime from they are created on purpose or just accidentally until found. And can you influence this time? No. The only thing what you can do is that you try to minimize with secure coding practices accidentally created vulnerabilities in your own source code. But that's the only thing what you can do. On the other side, then this vulnerability is found. You have the good guy and the bad guy. The bad guy is just hiding this information, using it for attacks, selling it in darknet, whatever. The good guy is going now to a vulnerability database saying, hey, I found this vulnerability. It's rated with this CVSS value, and here, give me some money. And then the information is available. So this is a good thing. That means what vulnerability database should you use? Generally speaking, this market is a high value market. So this is really expensive market. So I'm selling my vulnerability today to this one, next time to that one, because they're just paying better. So in total means you need something that is merging different vulnerability databases. And this is exactly what we are doing in JFrog. Our research team is not only searching for new vulnerabilities, but they're aggregating all this from vulnerability and free available and whatever, all this vulnerability database to make it in one big superset. And then can you make this, what can you influence here? You can pay for this merge if you like it or if you don't like it, but that's the only way what you can do to get this information faster. But on the other side, if you have this information, the main thing what you can do is you have this information now, and then you have to kill it in production as fast as possible. So if the information is consumable for you, however you are getting this information, until it's fixed in production. And this is where you should focus first, so automation and so on and so on. So I'm just running a little bit about this difference because I see quite often that people are have a misunderstanding about what is a vulnerability and what is a malicious package, because malicious packages are really a big thing and growing thing right now. So vulnerabilities, unintentional or intentional, these are more or less security bugs or backdoors. They're really baked in, and you will find them mostly marked with CVEs as common vulnerability identifier. So this is a number for each vulnerability. With malicious packages, it's not the case. They have no CVE, so they have no registration. They have no identity. Okay, that's just the case right now. And malicious components is more or less you have a piece of code with malicious payload code. So what are infection methods? What could be something that's important for you? With this type squatting, masquerading, and so on, I will jump a little bit in this. So for example, you have this type squatting. So if you're defining dependencies in a code and you have a typical typo, what people are doing, they're grabbing original source code, they're modifying it a little bit, pushing it to central places, and just with this typo. And if you're typing this typo, okay, then you're grabbing the wrong dependency. It's doing the same, but with a tiny extra. The next thing is masquerading. Masquerading is something they try to make a copy of this. They really copy metadata and so. But what you can see is maybe the same name, the same metadata, and it looks like the original one. But then you see something like weekly downloads or no really download statistics and all this stuff. It's more or less they try to look like the same. They're not going over this typo. They really try to fake the whole instance to present it so that you're loading it from there. Okay, it's just an example. I'm not going into too many details here. But the next one is destroying packages. You have really some libraries that are really good working, something like a good working PDF library. Sometimes this code is stolen from somewhere, then just repackage and all this stuff. You have good functionality, but with a tiny extra feature that is, brought in. So this is more or less a Trojan package. You're getting something with an additional functionality. And then there's something that's called dependency confusion. That's something that is interesting, because if you have dependency management tools with automatic version or with version ranges or automatic version increases and all this stuff, what you can do is you can, with the knowledge about company internal dependencies from external developers that left the company and all this stuff, you can create the same dependency with a very high version number, push this to official repositories, and then there's a resolving mechanism. It's mostly like looking in your own repository. Oh, here's version 2. Oh, I found this in this official repository with version 10. And then grabbing this one. And surprise, surprise, you have an internal dependency fetched from outside. This worked with nearly every company that tried it. So here you need something like a dependency resolution, so that you can say, for example, in Artifactory, okay, just this package, just resolve it internally, not externally. Okay, hijacking is one thing that old open source projects are reactivated by someone else. Is taking it over and then changing the meaning. Or what is, right now it's, you should heard about it. For example, is that some people make it like a protestware, so they're hijacking their own project. Mostly it's done by some kind of political motivation or whatever. Okay, so we have different ways how packages are, advanced with malicious code, and to identify this one is not so easy because you have different obfuscating techniques and so on and so on. What are the common payloads? So most people know sensitive data stealers, so searching for credit card numbers or tokens or environment variables. Okay, just searching for AWS blah 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 and grabbing and sending it home. So this connect back shell is more or less you have something and it's pinging back and waiting for commands, and download and execute is just, okay, I'm here, I'm downloading, I'm execute something, and one thing that is sometimes executed is, for example, crypto miners or whatever, so stuff. So we have different things. By the way, if you want to learn more about this, check out research.dryfrogcom. This is a page from our research team, and you will find a bunch of new interesting things there. What you as a developer can do, okay, the time is running out, I'm running. What you can do as a developer is, with a very good, strong test coverage, you have the best safety belt, because what have you to do? You need a very efficient dependency management, because this has the highest impact. If you see there is a vulnerability in this version, what should you do? You should change the version up and down, so that the whole composition will have the lowest amount of vulnerabilities that are important for you. Okay, and this means if you have a very strong test coverage, I love, for example, mutation testing, then you are very fast. If you have a low test coverage or weak test coverage, then you have challenges, because then you're not fast. Otherwise, you're just changing dependency versions, let the test run and deploy, and you are done. Okay, so if you want to know more about mutation testing, well, check out my YouTube channel. By the way, if you like it, subscribe it, please. And yeah, so short words about the cybersecurity executive order. So Mr. Biden, the US president, after the Solarwinds Hack, had the possibility to change the way the US government is working. Like a CEO of a company, you can't change the law, but you can change the way how it operates. And the basic idea here is that they started talking about an Sbomb. So everything that is used, run, owned, created by the US government must fulfill this Sbomb, this full list of all components in all versions. And even if you're working somewhere in Europe, can be that you're influenced by this because you have to deliver an Sbomb soonish. But it is good to create an Sbomb, because with this you have something like a full list of ingredients, so that you don't scan production, you just scan this Sbomb, and other tools can read this Sbomb. So if you have this provided with your packages, it is in good behavior. We know it since a long time. Before it's called Sbomb, we call it build info, and build info is more or less the Sbomb. It's part of it, and then a whole superset of the context during the time you're creating the binary. Means during the time you're creating the binary, you are looking at, okay, what's the agent name, what's the binary, what's the data, time, library version, and so on and so on. Collecting all this information, because if you have something, you can start analyzing the whole context, not only the binary, but you can scan the whole context where this binary is created, and then you will identify, for example, oh, it's always happening if it is built on agent number 3. Okay, just with the Sbomb, you're not able to do it. You can create it on command line, you can create it inside the CI environment, and so on and so on and so on. And then there's this build info. Build info is a superset of this one, and you can store it in Artifactory for sure. And you can read more about it here. And I have created more information in a video about it, so to explain all the details and stuff and so on and so on. So what should you read? You should start with reading the project Salsa, because there it will be the whole change from source code to binaries, what can be attacked, how it can be attacked, and so on. This project Salsa has two main components. One is source, build, and dependency threads, and the definition of, okay, what happened, what are prominent examples, what you can do against it, so that you are able to understand what are the critical points. But the short message here is you have source codes that can be manipulated or compromised, binaries that can be compromised, and infrastructure. You as a developer, you're not influencing infrastructure mostly, but you can influence the binaries and the source code. Okay, and then they will give you advice what you can do in each stage. We have not enough time so that explaining it here, but this is a very good point. And then they have the second part in Project Cells as an open source project, documentation project from the Linux Foundation. If you want to have some kind of implementation of this, is another open source project that is exactly securing the time from you start building that stuff until it's delivered. And this is an open source project for open source projects. And this is more or less a decentralized package management with build layer and distribution layer. It's a very fresh project. And I can really motivate you to work with this project or try it out. It's more or less you try to grab the source code, build it on different nodes, make sure that you have no compromised build infrastructure. And if this is the case, then you're pushing it to decentralized package management and you have connections to Docker Hub and Maven Central and so on and so on. So a bunch of big companies are working for this project, and it's growing fast. So check out Persia.io. It's really a nice one that is focusing on hardening the way to build open source binaries so that you don't have to fight against this compromise build infrastructure. But you as a developer, it makes sense if you're shifting left more than just to the CI environment. CI environment is important. But if you have this with an IDE plugin, for example, this information about your dependencies inside your IDE, you're typing the dependency, you see, oh, you have vulnerabilities, then you can decide what should you do and what you do. And if you're changing it, then it's saving a lot of time. Otherwise, you are coding the stuff, pushing it to CI environment, then CI is complaining. It's just way too long. You can do it on command line as well. So if you have a Docker image pulled down or whatever, just scan it on command line before you're doing it. You don't need an IDE or whatever. So use advantage of CLI approaches. And for sure, you can scan or inside the Artifactory or inside the JFrog platform, there's a free tier. And then you can ramp up the free tier, and then you can do all this stuff, unlimited in time, but for free, and for open source projects or even for your closed source project, but with limited resources. And don't forget your additional environment. So if you're using Docker Desktop, for example, search for plugins so that you can scan your Docker image there. So try to use this information as fast as possible in many places so that you're always aware of what are the vulnerabilities, what are the issues here. So what can you do as next? First of all, you can subscribe to my YouTube channel. Okay, I mentioned it already, so thank you very much for this. But on the other side, search for free webinars or workshops where you can attend. Sometimes in your local Java user groups, meetups, whatever, you will find some talks or some workshops where you can attend. If you want, you can invite me for workshops, or you can attend my free JFrog webinars and workshops. And if you have any questions, or if you want to know more, or you have questions more, feel free to connect via all the social media like LinkedIn, YouTube, Twitter, whatever fits best to your needs. I really would appreciate to see you there and have a discussion. And that's more or less all. And we can start with the Q&A, I think.
Yes, actually, we have a question, and we actually are running out of time, so we won't have too much time for this. But
Okay.
first of all, thanks, Sven, for this talk, for sharing all the information, for supporting Ukraine. And yeah, question is, what vulnerability scanning is available in Artifactory for open source projects for free?
So you can scan all technology layers. So if it is NPM, Docker, operating system, everything. So all package manager you have, you can scan all of them. That's it. The only limitation is that for the free version, you don't have all the knowledge from the paid vulnerability databases. So, but you can use
Okay,
it
thank you.
inside your IDE and command line interface everywhere.
Thank you, Sven. We are switching to break to give the next speaker time to prepare. Thank you very much. Have a good day.
Okay, thank you.